Hello, everyone. Welcome to this talk. Today, I'm going to discuss about our journey of transformation with GraphQL in Booking.com. As you can imagine, we started with a monograph phase. We switched to federation, but we have challenges always, and we have things to do to support ecosystem community in Booking.com for GraphQL perspective. And starting with why we have chosen GraphQL, we are a heavy experimentation shop. Actually, in Booking, we are heavily investing experimentation for enabling features for our clients, for our users. But due to how it looks like in the screen, we had a very complex client-to-server communication pattern for different parts of the domain. Like we have a couple of domains: accommodations, flights, attractions, taxi, and cars. So that part was creating a lot of inconsistency in between user experience, which causes us to lose a lot of time in experimentation, during the experimentation, and we were getting a lot of unconclusive results during the experimentations. A little bit glimpse of our scale for experimentations. We run 1,000 experiments at any time in our clients or in our backend services. And we run 25K experiments whole year in Booking.com. Apart from user experience, we were obviously lack of monitoring which part of the interfaces that is provided by backend services to the clients. We were lack of monitoring that GraphQL could bring. These are the most obvious reasons why we have chosen GraphQL. There are most of other good things about GraphQL that you know of already, but this is how our journey started, actually. Overall, if we look at the phases of our journey, we have started with a monograph phase. We switched to Federation Gateway on 2022. And now we are in a phase to switch Apollo router. We are an ongoing initiative to switch to router, get benefits out of the router functionalities, performance, cost cutting, cost saving, and features like fine-grained authorization capabilities and stuff like that. We started with a monograph. We started that as a schema stitching layer, as everyone does. And at the beginning, we selected the highest traffic, highly complex business environment of us, which is accommodations. We sell around 1 billion reservations per year. That is the most critical part of our business. We wanted to start with that part. And thanks to our front-end community, full-stack community colleagues, because in the meantime, they were also in a journey to transform the front-end stack into server-side rendering micro front-ends. And they also pushed a little bit GraphQL as a standard way of communication. Our monograph layer was a quite thin layer, actually. We intend to keep it small because from the beginning, we know that it is not going to be a eventual solution for us. There will be problems about monograph. That's why we prevented business logic to leak into monograph layer. It was just transforming GraphQL requests into the style of the request that is exposed by backend services, like REST and like a custom protocol that we are using proto over HTTP, custom style of communication. But there were a lot of problems about monograph setup related with developer experience, related with performance, and schema governance and quality side. Actually, most of the problems was around developer experience and performance side of the things. We were having a team maintaining monograph setup, actually, handling all merge requests coming from other teams, since they were just transforming GraphQL requests in the format of their backend services, how they expose. If it's REST, they were transforming GraphQL into REST. If it is proto over HTTP, they were transforming into that one. But the maintainer team for Monograph was a lot overwhelmed when the community integrated with Monograph has grown up. Actually, at some point, we reached like 35 subgraphs integrated to Monograph just to translate their requests into GraphQL and back. Performance issues and technical issues due to a monograph setup. People were making changes, rolling out their changes, but it was causing problems, like it was impacting other use cases. It was impacting the performance perspective potentially, even if it's a thin layer, actually. We had problems related with third-party library that we were using to generate the telemetry data, generate the traces, and emitting the traces to the Apollo platform. And last is schema governance and quality. Actually, when you don't own the GraphQL schema, you tend to just do it and move forward. Like, you don't care about schema quality, you don't care about like design principles of best practices. You just map the GraphQL types to your system, like types that you are using in the REST endpoint that you own, and move forward, which is like causing a lot of issues in the long run in the schema quality perspective. A little bit of glimpse about what happens if there is performance issues in the monograph setup. 20% latency increase causes a lot of bookings lost for us, around like 250,000 euros. This is too much. So we decided to move forward and adopt federation gateway approach. Our monograph was the first subgraph of the federation gateway. We helped people to migrate their schemas out of that single subgraph interfaced by federation gateway. And we encouraged adaptation internally in the company. Now we have 140 subgraphs behind client-facing federation gateway. We handle 8 billion plus requests per day, which corresponds to 100,000 per second. And we have clients as native clients. We have 120 million active clients in the field. We have web clients, and we have internal service clients handling server-side rendering, working as a micro front-ends. Also, of course, we get a lot of benefits from the Apollo platform, like fine-grained monitoring, entity concept. We benefit from it a lot for many use cases. We also centralize the schema operations to make it safe and easy for integration with the federation platform, for new use cases, for new features that is released in the backend services for different use cases. As you can see, there are some numbers. We measured this some time before, but our time to market shipping products are now 40% faster. With schema checks, this is important for us because we have a high amount of native app users in the field. So, and we have app tail versioning problem. We have to maintain 2 years of the app versions in the field. That's why checking schemas before rolling out something to the supergraph is quite important for us to prevent breaking changes. Another thing, consistent user experience, which we get unifying the interface between client and backend subgraph services. And of course, developer experience improvements. We have much more happier developer community. They easily can ship their services, expose their services to the clients. Also, they are not have to dealing with monolith or monograph issues like impacting each other. They don't need to wait for release cycles of the monograph. They can ship quite faster compared to before. I wanted to show a little bit of data around that. I think schema publish counts is a good indicator showing how effective it was for switching to federation. When we start adopting federation, we were having on average 12 schema publish counts, and average for the last 2 years is 84, and we have 175 at peak. It was impossible in the previous setup to ship this much changes in the production. With federation, we have improved developer experience a lot, which increased the productivity and so on. This is another use case, strong use case internally supporting Federation Gateway. We had real benefits from Federation Gateway, and we decided to apply that for service use cases. We were having problem in the backend services that needs materialized data to access different kind of databases, which is suboptimal. You cannot connect each and every database from each and every service that needs that data. It is a little bit waste of time for non-productive. Actually, that's why we put Federation Gateway in front of the data source that provides raw data to the subgraph services, to other kind of services, which can be consumed easily through Federation. They can fetch data, transform, locally store their preferred local storage and consume it actually. It is also important in terms of performance, because these databases might be a bottleneck and it is inefficient to fetch data for this kind of use cases online way. So we created this federation and put it into our stack for this use case. But with federation, we still have some risks. It is not completely safe. We need to put some measures around that. For us, query level latency overhead is an important monitoring metric on federation level. That one shows how much time has spent for an individual query on the federation component itself, which provides us a lot of insights, because I mentioned, we are heavy on experimentation. Queries change a lot. Query plans generated a lot. And due to experimentation, size of the responses could vary. If anything, like any performance degradation we discover in federation, without this, it was impossible for us to identify quickly what is the root cause of the performance issue, which query is problematic, and take action. Another thing, another important thing that we are using, timeout budgets. We enforce timeout budgets all over our request call stack. On federation, we control those budgets by looking at the query plan, actually. During a request, we actively change the timeout budget by calculating remaining time. For example, if there's a subgraph call, we calculate how much time it took. We subtract that from timeout budget and start the subsequent call to reduce the load on our services to be safer on the federation level as well. Schema caching, that was a resilience reliability related service that we introduced before uplink relay was released. There could be issues in fetching supergraph schema from platform, network issues, any kind of issues on the platform side as well. With this, we localized the schema, supergraph schema that we fetch for federation gateway, and it helped us for a couple of incidents that we had before. Lastly, we have all kind of monitoring and alerting over SLOs like availability, overall latencies and performance metrics on federation level, which turns into alerts and which turns into like monitoring dashboards for us to keep track the federation health. Even federation was actually like a best way to go for us. There were a lot of challenges around that. During federation migration, we also had migration on infrastructure level. We used to have a cluster maintained by booking.com itself, booking clusters, but strategically we decided to use AWS, and we started migrating services, migrating data processing pipelines to AWS. And of course, some subgraphs decided to migrate to AWS. We had to provide support as platform team for these migrations. We are relying on Envoy heavily for service-to-service communications. At first, for migrations, we used weighted traffic shifting controls provided by Envoy. Later, we switched to Federation provided override directive to shift the traffic from one service to another during the migration. Another challenge for us is enabling GraphQL for legacy services. We still have PER services, which is ancient. We provide wrappers, we provide templates to wrap those endpoints. That is already part of PER stack to decouple them, to move forward in the client side and leave room for them for migrations, actually. Another challenge for us was community education and schema quality. For schema quality, I will talk about that later. We implemented an internal tool and schema scoring mechanism to keep track schema quality. But other than that, we have schema design support. We have governance champions, internal community. We provide internal meetups to the GraphQL community, so on and so forth. Lastly, most challenging stuff is experimentation and deprecation strategies due to experimentation. It was painful at the beginning. People were asking how we should design our GraphQL schema to allow experimentation, what to do in case we want to expose something, what to do in case we want to experiment on an operation, and what to do when we want to change the value of a specific field that we return in scope of an experimentation. For those, we had to provide guidance, we had to provide support for all of the teams that is part of GraphQL stack. I wanted to show like how it was looking like. Actually, I mentioned a challenge around infra migration. The challenge brought some kind of complexity for us, how we should handle the GraphQL requests. Because we have a single supergraph, we had to support federation gateway in both data centers. But the problem is that since we have a single supergraph, providing supergraph from both infra setup would bring challenge of cross-cloud communication, which incurs extra cost, which incurs extra latency for us. That's why we designed a routing logic closer to the edge, which keeps track of the query plans for individual queries and make routing based on the majority of hosting for subgraphs for an individual query. If majority of subgraphs for a query plan hosted in AWS side, it routes there, otherwise to the other side. And yes, we had to deal with a lot of stuff internally to support Booking GraphQL community. It's a big community. There are a lot of challenges related with schema, integrations. How should we design schema pipelines? How should we integrate services? To support all of these, we designed a schema scoring system and a schema scoring mechanism which provides information to the subgraph owners about the quality of schema. From our GraphQL maintainer team, we provide support to the integrators or like the people maintaining their subgraphs in the ecosystem for applying schema design best practices. We have a bootstrappable CLI which generates Java or Node.js based service templates already integrated with our internal publishing pipeline, which handles all CI/CD for subgraphs, and also providing some like basic examples for entity resolution, for requires directive usage built in the template. We have internal champions board, which deals with the overall quality of the schema, making like wider scope decisions. We have traffic insight service, which keeps track of the query changes and notifies the subgraph owners against potential increase of the query of the traffic loads due to changes on these queries. Imagine somebody adds some field or adds some resolver to the query, and the service supplies the data for that, has not enough scale to handle that. We use this service to give a heads up to the service owners to scale accordingly. And lastly, we have schema caching service. I talked about it before. Schema scoring. Yeah. Schema scoring. We saw a lot of problems in quality of the schema without an automated system making an assessment over schema design, schema quality. It was hard to improve or keep track the issues. So we started a system that relies on these elements for now, initially. We check for each and every publish of the schema, we check linting related stuff, which is like naming conventions, format related stuff, you know it. Second, we check stale fields. We benefit from Apollo backed data, how much relying on the last 30 days data to cross-check how many of the fields in the schema is being used. Cyclical types, that could be a problem in terms of readability. We discourage it. We also check cyclic types, like types depending on each other. We check percentage of it across the all subgraph schema. And lastly, nullability blast radius. We check how non-nullable fields could impact how deep they're linked in the type system and how much it could affect if there's a problem. This is how it looks like. We have subgraph level maturity scores. We are giving insights to the subgraph owners. Also, we have overall maturity score for supergraph schema, where we provide insights to the governance board, like champions board. Like F means you need to take care of this for the long run, for nullability blast radius. We are not blaming anyone, but we encourage to like improve the schema quality internally for the long run. Because there could be cases like this, I wanted to share this because this happened recently for us. You know, requires directive is being used to share data across subgraphs in scope of a request. We expect normally to get a couple of fields as an argument to the required subgraph, but this happened. Some people put whole data that they receive from initial call to share it with the subsequent one. To prevent this kind of stuff, we will improve schema scoring tool internally. And this is our plan. Like, obviously, we will check requires directive overuse. Similarly, we will check compounded keys overuse, actually. We have heavy requirements in terms of authorization, authentication. We have separate, like, special directives for them. We will check if they are used properly for sensitive fields identification, authorization, and authentication. And lastly, we use contact directive to tag schema with the information about like how you can reach out to the team during the on-call, during problems, and we encourage the usage of it properly for subgraphs. And this is my last slide. I wanted to share, we are in a phase 2 switch router, and we already got performance perspective, really good results for complex use cases with mirrored production traffic. We reduced from 200 milliseconds to 10 milliseconds for search use case and for property page, like which is like showing the property or hotel data. For that use case, we reduced from around 100 milliseconds to 5 milliseconds latency overhead. So yes, that's what I'm gonna share for today. Thanks for listening.